Okay, perfect.
Yeah, I think Naman, you can start.
I'll
Okay.
start.
Yeah, Naman.
I'm sorry, has the recording started? Mahesh, can you please start the
Yeah,
recording?
YouTube live is going,
Ma'am,
ma'am.
this is a YouTube
So,
live session, so no
Okay,
recording
okay,
on chat.
okay, fine, thanks. Yeah, go on, please.
A very good evening to all the brilliant minds joining us today. I'm thrilled to welcome you to a special collaboration between the Industry Interaction Cell and the Student Placement Council at the IIT Madras BSc degree program. Today, we are honored to host a tech talk by a luminary in the field, a distinguished architect and the co-founder of Petavue, Mr. Jairaj Velleswamy. A warm welcome to our course coordinators Andrew sir and Vignesh sir and our head operations Bharati ma'am who play instrumental roles in orchestrating and guiding the success of our students. Your dedication and leadership are invaluable to the seamless execution of events like these. I also welcome the Industry Interaction Cell team under the able leadership of Suraj sir and Kamla ma'am, whose unwavering support and commitment to fostering industry academia relations form the bedrock of our endeavors. Last but not the least, a heartfelt welcome to the Student Placement Council team. Your dedication to shaping the futures of all of us is truly commendable. Before we dive into the tech talk, let's take a moment to understand the organization behind today's enlightening session. Petavue, under the leadership of Mr. Jairaj, is revolutionizing analytics for businesses by allowing users to communicate in their own business language. Petavue is eliminating the barriers of technical expertise in data manipulation. Today, we get a glimpse into the future of analytics driven by advanced AI technologies. Our esteemed speakers has not only been at the forefront of building and delivering large-scale enterprise products, but has also played pivotal roles in two early-stage startups, contributing significantly to their success. With expertise in database design, cloud computing, cloud security, and as a MongoDB expert, Mr. Jairaj has left an indelible mark on the tech industry. Today's session promises to be both enlightening and transformative. Mr. Jairaj, with his extensive background as an architect at ZoomInfo, will guide us through the intricate world of open source language models. For business use cases, his talk title, Picking the Right Open Source LLMs for Business Use Case, is poised to offer invaluable insights into navigating the dynamic landscape of advanced AI technologies. And at the end, he will be answering all our questions and on all the fellow mates present here and learners can actually type in their questions, which I'll be facilitating and communicating to sir after he finishes. So further, without making him wait further, I call him up on to enlighten us.
Hey, thanks, Naman. And then, thanks everyone to give me this opportunity. I'm so happy to, present this today. And my name is Jay Raj, co-founder and CTO of Petavue. And Naman pronounced the name Petavue. I like that name quite, it's actually the actual pronunciation is Petavue. Um, you can view or analyze petabytes of data. That's the dream name we kept. Uh, yeah, thanks once again, for giving this opportunity. Yeah. So uh, next, probably 30-40 minutes, we're gonna discuss a few things about how the whole large language model landscapes are moving. What are the strategic approaches that we should consider before building business applications, especially using large language models. So we'll just go through bunch of open source models and then few discussions, challenges, what are the different metrics, techniques that you can use to build a a better business or better application. So let's jump into this. Let's say, before going to the details of any other model or large language model, let's understand what exactly today, the large language models are solving. And we just, understand what all of the challenges today exist, and how even this, language models are trying to solve that problem. If you take, let's say, natural language understanding and generation, the NLP as a field has been exists for long period, but all of a sudden after Chat GPT, we know what have happened or what's happening today. We know that, right? So one of the key area where large language model could really solve problem for the business today is natural language understanding and generation. That includes your language translation, or it could be a text summary or content creation. All these natural language specific things can be easily solved by using large language models today. The other category is information retrieval and organization. This is where most of your Q&A, chatbot, search based systems are there, right? So before large language models, people would have configured a chatbot manually. You go and give bunch of rule based questions and answers. So that is the rule A, this is how you should drive. If it's the rule B, this is how you should drive, right? So all these chatbots or information retrieval systems were operating very rule specific. But now, with help of large language models, this could be more towards language understanding, and semantic based question answering is possible today because of large language models. That includes, as I said, your question answering, Q&A chatbots, knowledge extractions. In fact, today there are so many cool applications, even existing enterprise application releasing cool features where you go and extract information from the large enterprise systems just by using simple English language. The other important area today where LLM could fit, and it could solve the problem, is natural language to code and SQL conversion. This is one of the very, very broader and very important area today when it comes to programming, data analysis, and on all these fields. How can you convert a simple natural language to actual code? That code could be your Python or JavaScript or SQL, whatever. So this is where I want to emphasize, kind of the whole industry is moving towards a paradigm shift, right? So we are moving slowly towards from build time to runtime. So assume, so far someone has to go sit, write code, you compile it, and then build the product. But today, with the help of large language model, many of these things are slowly moving towards runtime. A good example for this is ChatGPT's code interpreter. Today, they market as a advanced data analysis, where you can go ask a question, you can upload a file that could be a CSV, PDF, or whatever, and ask it to analyze. All of a sudden, it generates the code in runtime and then compile it, and it just takes your file, execute it, and give the result. So if you think, before large language models, someone has to go sit, write this code, you have to read the file, upload it, and then parse it, and then you have to extract the informations out of it. But today, with the help of LLM, this just move to runtime. You don't need to go sit, actually write code. You would have seen already a lot of copilots, your GitHub copilot, a lot of SQL copilots. All these things are based on LLMs. So that's where the natural language to code and SQL, it's one more good area where LLM could really fit, and it solves a lot of problem. And the other one could be sentiment analysis and emotion detection. Probably you could have seen already, OpenAI released a video based model where it could generate a nice video just by prompting. and a lot of image models, where you can just give a prompt and get nice, image out of it. And so all these, so many cool things are possible today with the help of LLM. And of course, sentiment analysis. You can just upload good reviews and you can ask a question. All of a sudden, you get some good sentiment analysis out of it, right? And then there's another areas, personalized recommendation. Again, so far this been done by traditional deep learning models, but with the help of LLM, a lot of all these recommendations also possible today. And of course, educational applications. Even these days, we are able to see Copilot in programming SQL. I'm seeing like a lot of Copilot going to come for educational related industry also, where a student can go ask a question, and then as a tutor you can set up a virtual tutor or a Copilot equivalent of tutor, where the artificial tutor can answer your question, it can guide you, it can assist you to prepare in a better way, right? So all these applications are possible today. And of course, the data analysis and visualization. I've given already a good example, the chat GPT's code interpreter. That's one of the very good tool that solves this data analysis and visualization problem today. Yeah. And like, since we already discussed where exactly or what are the problem it's solving today, or it helps to solve today, we need to understand what is the main role, how it plays, such a critical role, or why large language models become so easy to address these problems, right? So, or if you've seen, it was not possible today, or it was possible but uh, significantly difficult to achieve certain things. But with LLM, many things are like, becoming a lot easier today. I just highlight three things why it is easier today. The first one, its capability on generalization and flexibility. And second, we call it as a few shot learning. And third one, of course, the cost effectiveness, not in a up to the a broader level, but it's like up to some level it is cost effective. We'll come to that topic later. But when you say generalization and flexibility, usually these LLMs are pre-trained and a vast amount of data sets, right? That covered wide range of topics, not just languages, but code, maths, or, so many other problem solving, reasoning, like so many different, domain, data has been ingested and it trained, right? So it has a flexibility to adapt to the different, situation or a questions and answering without needing to go and train specific on a particular data. That's something usually will happen in the traditional deep learning models. So in traditional models, you often require a labeled data set. You go prepare the data first, and then clean it, and then you have to train the model. And when you just build it and start using the model, you also expect the incoming data to be in the same format, right? So otherwise the traditional model won't work in most of the time. So but where in which LLM has that flexibility, it could easily adapt to a specific domain just with the help of few short learning. Let's say what I'm saying, a few short learning here is, um, you know you can tell LLM in such a way that, hey, this is what your role, and this is how you should work, and these all are your capabilities, right? And you just inject, all these instruction. We call it as a prompt. So whatever things you are instructing to the large language model, we call it as a prompt. So you just play with prompt, and you give enough few short learning. Here we few short learning, what we mean is just giving more context, right? Okay, as a AI copilot, or as a SQL copilot, this is how you should work. Your primary goal is to generate natural language to SQL query. you know you should not make syntax errors. You should think step by step before conclude any solution or any queries. You should think about joins, subqueries, or a CTE expression. All these things you will put all these in a clear instruction and with few examples. Oh, if a question comes like this is how you should answer. Just like how to a small child or someone you instruct, right? Hey, if someone comes, this is how you should behave, this is how you should react. Such a way you just pack all these prompts with just few short examples, and all of a sudden your model started learning all these pattern, and it start working for your use case. That's the beauty of large language models today, where in which in the traditional deep learning models you have to prepare thousands of or hundreds of thousands of training data first, and you should you know uh, uh, you know um, clean the data, you should normalize it, and then you should spend time for training it, retraining. All these things are like time consuming a task. But today with LLM, this all you can pack in a few short learning, right? So just pack a few examples with proper instruction, boom, your quick application is ready. And of course third one is a cost effectiveness. So again, we are not going to provide any labeled data set and then training for each task, right? So it's just a single model that could work for different tasks. Take an example of your Llama or OpenAI GPT or Anthropic Claude, whatever the model, right? Just a foundational model where you just feed different prompts, set the persona, pack the examples, and then it just started working. You don't need to go and train a special model for each and every use cases. Of course we'll come to that part later where you might need that a special training on all these models. But in general, a generalization and flexibility, a few shot learning capability, and the cost effectiveness, these are like a main things. Today you can easily go and build business applications with large language models. Probably, since already we talked about what are the business and why it solves a problem, probably next question might come for everyone. Okay, how to start or where to start, right? So to answer how to start, as I said, prompt is nothing but just English. In fact, even we often say that like the prompt is going to be, or English is going to be a new programming language these days. you know I've seen people, a lot of software engineers in the industry these days, like they are using GitHub Copilot a lot. And in fact, I heard some stories where the day joins, first day they asked a question is, will you give GitHub Copilot access? Because like it's kind of now integral part of the programmer's life. So you don't need to spend too much of time on writing code from function name and then declaring the variables, writing loops. No, it's like give me a function for binary tree, search, binary search tree, boom, all of a sudden your fundamental code block or a snippet will be ready. And then you can just go replace the variables or your logic, and then boom, you're done, right? So we can quickly move ahead. So that's where sometimes people saying like English or a prompt, it's kind of a new programming language. So that's where we can start. And then little bit of advanced thing, when we really wanted to, we can go with retrieval augmented generation and then fine tuning. We'll come back later what is the RAG and fine tuning is. The next question, where to start? Of course there are good open source models, and then few closed source models where you should pay and use. A best place you can start is you can go to Hugging Face, create an account. Hugging Face has a playground, you can start play with that playground, choose a model, and then start giving your prompt, start play around with that. Or if you have an account in OpenAI has something called OpenAI Playground. You can go give a system prompt, and then use a prompt, ask a question, it start answers. And then again, any scale provides these things,
Vilasha, did we lose Mr. Jairaj? Naman,
Yes,
can you
ma'am, it
hear?
seems. Ma'am, he's back. He's back.
Okay.
Sir is back.
Hey, 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 Naman, am I audible?
Yes, sir, you are.
Okay, perfect. Okay, perfect. Sorry, some internet issue, I guess. Cool. So I was telling about where to start, right? So you can go to OpenAI and then start with Playground. Start giving system prompt, some user prompt, and then you're ready. Or if you really want to build something seriously, you can start exploring with APIs. So you can go and choose OpenAI APIs, and then you can play around with small prompts and then start building, small applications. Any scale also provides API as a service. You can use it, and AWS Bedrock also provides all these LLM as a service. So you can go choose the model, and then you're set. You can start play around with all these large language models. Cool. Okay, now let's say you're set, you're ready, and then started playing with this prompt. um, of course, large language model comes with its own limitation or its own challenges, right? So the bigger challenge today is the hallucination is a bigger challenge, where you're asking a question, uh, the LLM might not understand, or it might not interpret really well. It can start throwing some random answers, right? That we can call hallucination. uh, you know and then the another bigger problem today we see in the industry is limited context window, because you can't pack everything, whatever your enterprise data, everything in the large language model. So it has something called context window, the prompt in which you can pack maximum certain amount of data. That varies, depends on the model. Llama could go up to 4096 token, where GPT 3.5 Turbo will go up to 16K. GPT 4 Turbo will go to 128K. Anthropic Claude has 200K. So all these different models has different window size. Though it has certain model, the recent model has more than 100K, 200K window. End of the day, we call it as an in context learning. So you can't pack everything in the prompt. Means, though you can pack like multiple thousands of line, your model cannot digest everything and give you the correct response. There is a high chance it start hallucinate, it'll start missing the context, and then it will start randomly giving answers. So this is one of the major problem that today we are facing in the industry. And the third important problem is explainability. This is one of the crucial problem today, right? So so far, assume you have an engineer in a company who writes a code. You can go and ask an engineer, "Hey, can you explain this code? Why did you write this code, or why did you build this logic?" So as a human, someone can explain, "Oh, this is how I came to this solution." uh, but where in which an AI, you're just giving something and you're getting something, right? So you get an answer, but you do not know how LLM exactly generated that answer. So there is no explainability over there. Without that explainability, it's very hard sometimes to you know parse the output. So is it correct or not? Is the thought process of the LLM is correct or not? uh, is the understanding is correct or not? Is it truly understand my problem and generate the answer? So we do not know all these things, right? How it is even generating the answer. So the whole explainability missing over that, that's one more bigger problem. And the fourth problem is, of course, data privacy and security. Of course, if you're moving towards open source models and you're hosting it in your own cloud environment, it's fine, still it's good. But when you're using LLM as a service from OpenAI or from Anthropic or from any scale, still there might be a question, how the data is going to your model, how it's being processed, will it's being stored, or will it, what about the logs, where it is being stored. Bunch of questions might come related to data privacy and security. And again, when it comes to security, there is one more new field is emerging today. It's called prompt engineering. Probably in programming we call it as it's not a prompt engine, prompt injection, sorry, my bad. Prompt injection, if you think in a programming world, we call it a SQL injection, where there is a SQL query, a man in the middle, someone can inject a malicious code or a content inside a SQL query, where it can go and do some, a malicious, activity, or it could go drop your table, or it could does some nasty things in your database, right? So that's we usually call a SQL injection. The same way today, it's happening in the prompt. When someone's sending a prompt, in between can inject some malicious content that could go and lead to so many different problems. Like it could go and get some of your data and send somewhere, or it could lead to some infinite loop where you will spend a lot of money on token generation and bunch of other issues. And of course, the last one, cost of training. Today, a pre-training a model is insanely expensive. In fact, inferencing also significantly expensive today, with the GPU cost and everything put together. It easily comes, even in Petavue's case, we did a good benchmark recently. It came around like $3,000 per month. So it's very costly today. Yeah, these are some of the challenges on building applications by using LLMs. And of course, when there is a challenge, we need to somehow solve it, right? So few techniques that could help to solve these challenges. The very basic and the very important one, it's better prompting techniques. It's very simple. The prompting techniques are very simple. You can give a very clear instruction. The prompts should be shorter. It need not to cover like multiple pages of examples and everything. It should be short, and trying with few short examples. If possible, you can give some chain of thought. Chain of thought means like, hey, as a SQL expert, this is how you should think, this is how you should interpret this question. So basically you are injecting some of the thought process to LLM, that helps LLM to think and come up with a better solution, right? So these are a few techniques. Other technique, you could go for RAG. It's a retrieval augmented generation. uh, this somehow avoid to help context window problem, not fully, to some extent, because you won't pack now all the relevant context to a prompt, where you'll just go and do some similarity search, get only the relevant content from your vector DB or vector storage somewhere, and then just inject into a prompt. And of course, RAG has its own challenges. That's a different discussion altogether. The third is very important, and then it helps a lot even for us in Petavue and in general, a lot of companies today using something called function calling. This especially in OpenAI based GPT models, it supports really well. Um, I think probably like 8 to 10 months ago, when so many things are very new, and then we started to prompt engineering, we remember, uh, you know, you're asking something, and then LLM gives a response, but not the way or the structure that you expected. So usually I'll tell, a this is my content. Your job is to go and generate a SQL query from my natural language by using this is database schema, and give me the output in a JSON format with this particular key, and the value should be something like this. You specify all these key value as an example and pack it. But even after packing, after giving all these clear instruction, the model will started throwing random answers in a stringified format, or not even in JSON format. It just started throwing in a simple text. Hey, as a AI model, I'm able to generate, you know, so many blah blah things. Like it started explaining, it started, writing its own story, and then in between inject your SQL query. It's very hard for us to, parse all these text, eliminate all these noise and then extract the SQL query. Right? It was like super complex in the early days. And then after I think GPT introduced this function calling feature, it controlled a lot. We, especially in Petavue, used a lot, to get a very good structured data back from the model. And then the fourth one is A/B testing with multiple model. This is one more good area where you can go experiment. If someone very serious on building LLM based application, you should really, explore all these multiple models. Uh, what is mean by multiple models here is you don't try to solve all the problems using one model, right? So let's say your core business logic or core business problem can be solved by a very good model. That it could be a GPT-4 Turbo, or it could be Claude. It's like a good foundational model where some of the semantic routing, or based on the question, based on the semantic, or based on the difficulty, you can do a lot of routing. Let's say when someone asks a question, you should, I'm giving a simple example, right? So let's say you have an application. It has to, take a question from the user and go and search from a large unstructured data. You have like a corpus of data as a text file, or as a PDF file. And also you're providing solution where it takes some data and it has to go and uh, get some output from a structured data. In this case, you can place a router model. It should decide, okay, the question is related to programming or related to SQL. You just go to path A. If the question is related to unstructured data, or the question is related to something where I have to go and do some semantic search or some summary, go to path B. In the path B, you can put a model like a Mistral 7B, or a Llama, like open source model, or even a smaller model. Usually the smaller models are really good at natural language to natural language conversion. You can use such models to solve that problem. Where in which to solve the SQL problem or programming problem, you can send this request to a better model that's trained on code. Let's say, for example, Code Llama, or some other model that's really good at solving the code problem. If it is a SQL, you can pick something like a SQL coder, right? So all these different models you can route based on your question or semantic or whatever the difficulty. And finally, so fine tuning. It's one of the broader a chapter. It's a kind of a way you just give your domain specific data and the pattern, question answering and everything to a model, and then fine tune it so that you don't need to pack all these RAG or better prompting techniques. So basically fine tuning is a way of improving a model to solve your industry specific problem, or your company specific, or your business specific problem in a trained way. So that's something called fine tuning. Yes, I mean, like a lot of things we discussed, where it fits, what are the problem it solves, how to choose, what are the challenges, how to solve all these challenges. And as the title says, how to choose LLMs, right? So if I say now, okay, it depends on your use case, then you might feel like, then why are you even here? We thought you will come and say something about, oh, this is how you should choose model. But if I'm saying like, oh, it depends on your use case, and this answer everyone knows. But sadly, partially this is true. Yes, it still depends on your use case, your business need. Let's say you have a business or you have a use case. What's important for your business, right? So is the accuracy important for you, or the speed, or the consistency, or the cost? So based on these different metrics, you should choose model. That's a kind of a generic framework I can come up with, right? So you have a business, let's say, um, you know some kind of a movie review. So your platform has to give a or summarize a movie and then give a rating or whatever, right? Or you have an application that should go and scrape all the reviews from a or comments from a YouTube video, and then it has to give a some kind of sentiment analysis. Is accuracy important for you, or consistency important for you, or the speed in which you will get the answer from the model is important, or the cost is important? So these are the four questions you should always ask. Most of the business today, you should always go with accuracy. Again, it's not kind of a, a, a rule of thumb, but if you want really your a use case to work well, LLM to work well in your use case, I would always go with accuracy first, and then I'll go with consistency, how consistent the model is performing well, and then third I'll just go right. At third, I'll pick either speed or cost, depends on what x that varies. Let's say I have to pay 20x more cost for 2x performance, or improve speed, or speed improvement, then I would just go for I won't go for the cost at the time, right? So, or I won't even go to speed. I'm still happy to live with a model which is highly accurate and consistent, but it is relatively slow. But if my business need is accuracy and speed, then I need to choose a different model accordingly, or different deployment strategy I should choose accordingly, right? Because certain application I need a response in millisecond or in seconds, right? In that case, I can't compromise on my speed. So at that time, I'll pick accuracy and then speed. Of course, for that, I might have to pay the cost, right? So these are the different things that you should always consider before choosing LLM. But of course, selecting the right model is has to happen via a proper evaluation, experimentation, and that aligns with your business requirements, right? Usually, this is very complex and time-consuming task. Um, but really, actually, we have done some of the heavy lift at Petavue. Uh, what we have done recently is we conducted an extensive, natural language to SQL benchmarking across different models, and we completed over 55,000 inferences that varied across a different instruction size, different difficulty level, and different hosting environments. What I mean is we picked OpenAI, and in OpenAI 3.5 and GPT-4 Turbo Preview. From AWS Bedrock, we picked Claude and then Llama 70B. From any scale, Code Llama, Mistral, Code Llama, 70B, and then Llama 70B. And also in self-hosted, uh, we just picked all these models and we deployed it in our own, run pod instances, and we did really, very deep benchmarks. So some of the details I'm just quickly cover here. So we took a Spider data set. Spider is one of the industry standard open source data set for NL2 SQL benchmarking. Um, so we picked that data set, and then we put a lot of different instruction size that we packed in the prompt. We specifically go with went with 5, 7, 9, 11, 13 instruction, and 750 inferences for each size. So it comes around like 3,750 inferences per per benchmark. And then finally we measure the accuracy based on a test suite eval. This is something again officially available. It's an open source one. This is a kind of a official evaluation framework or a tool for Spider dataset. So we just picked all these models, different instruction, different hosting environments. We just ran all these benchmarks, got some result. So I'll just present some of the quick preview of the result. The detailed results and the framework and good articles are coming in couple of weeks. This is something, a small preview I'm just showing here. If you see, with different instruction size, different models, how it's performed on the spider data set. If you see, Claude V2, did really well, around 0.7, in this, in 70% accuracy you can consider. And then 3.5, 4 turbo preview, and then Code Llama 37B, then Mixtral 8 cross 7B. So of course, this is just a quick, a consolidated report. We have like super detailed reports and blogs that are coming in, as I said, in couple of weeks. So this is something very specific to natural language to SQL. We did a benchmark. So in fact, from Petavue, we're going to continuously release such benchmarks in a monthly basis, right? So we'll just go next month, we'll pick few other models or better data set. We'll be keep releasing all these things. So yes, this is something we did a really good comparison. And of course, we did with our own inferencing with all other cloud providers that include OpenAI, AWS Bedrock, and then any scale. So we just performed this benchmark across these different environments. This is about natural language to SQL use case, where in which Petavue invested a lot. We are focusing a lot, and yes, pretty much we covered why LLM, what are the business use case, challenges, how to mitigate that challenges, and how to choose a right LLM for you, and quick introvert, some kind of a a gist from our benchmark. This is something I prepared for today's talk, and I'll just give a small quick intro about Petavue now. So Petavue is a AI first company. We heavily focus on um, transforming raw data into a insights, how to convert a raw data to a insights. So that's our main focus. We operate, or we work on the enterprise data. We enable users to transform their data, from where it is available. It's from the source to insights. So, and then of course we use a lot of large language models, and lot of, in the sense, not just GPT or not just Claude. We used variety of different large language models for different purposes internally. And then we, of course, as I said earlier, we heavily investing time on moving towards this runtime architecture. And yeah, we building like very cool infrastructure for this runtime architecture, where people can bring unstructured raw data, transform them, analyze them, and predict, uh, not in weeks or hours, probably in minutes. So that's the a business, or that's the product that we are building at Petavue. So yes, that's about about Petavue and today's talk. Now I think we can go for the questions.
Thanks a lot, sir. And firstly, I'll apologize to you for mispronouncing Petavue, and I'll stand corrected from now on. And so
No issues.
it was truly insightful listening to you, sir. I've gained a lot of more perspective. My horizons are expanded, and the way you started, the way you had made it a complete package from starting to the scope and businesses to getting to the detailed architecture part to detailed analysis. It shows how analytical you are and how enthusiastic about about what you do. And it is reflected, sir, in the talk. We have a lot of questions that came to us, and if you allow, sir, should we begin?
Yep.
Okay, sir. So the first question that we have is, how is the use of LLM in product recommendation different from traditional methods?
Okay. I mean, the question, if I'm understanding correct, so product recommendation. The question is about product recommendation. How to use LLM in product recommendation? That how you will compare that with traditional deep learning models. Is that the question? Correct?
Yes, sir.
Okay, awesome. Yeah, in a traditional deep learning methods, so we build recommendation engines, right? So using different algorithms, especially I would say some of this market basket analysis, or other good analysis we do, especially when someone buying a product, similar product has to be suggested. If you think in deep learning, in traditional models, we need like you know um, tons of data, at least like a few 100,000 data to get a better model that not biased towards anything, or that's not overfit on anything. So we need like carefully crafted data, and then we need to do a lot of training and retraining. The secret sauce of large language model where it could help is, since it has a kind of a generalization capability, you do not need to go and train from scratch. So in general, in large language models, what you do is you can show a sample A. This is my product A, this is my product B, or this is a user behavior. This user behavior, when user purchases product A, product B, and product C, where the criteria is age is certain, greater than whatever 20, or the gender, whatever the criteria. If such criteria matches, and there is likely this person can like other product. That's how this all the recommendation works. Correct. So where how LLM solves this problem is the same way. You show this few short samples as a data, even not even as a data. Most of the time it works just by looking the schema. Even in fact in Petavue we did, you know, you just give a schema, pass to LLM, and give the enough context what exactly you are expecting from this, and what are the product that you need to recommend to this guy. Just give another list. LLM can really do better on recommending products. It's not even about products, any recommendation. So you are giving bunch of criteria, uploading another list, and boom, ready. Like all of a sudden your recommendation engine will be ready. I would highly recommend or suggest. I mean, it's a good question, by the way. The person can go and play around with ChatGPT's code interpreter, so or advanced data analysis tool, where he'll get very good answer for this question. How exactly? I mean, he or she can play around with it, and in few minutes, he or she can build a cool application with code interpreter. So it's that's how just a bunch of prompts, and with good few short examples, and then the data that you want to predict or you want to recommend. It's good enough.
Thank you, sir. I believe someone has got his answer as well as a great idea to work upon now. So the second question,
Cool.
sir, is how will LLM be cost effective? A little more elaboration on the point you mentioned, like how will it be more cost effective?
Yes, I'll come to that, right. I know why the question comes. People would have seen, oh, OpenAI charging $20 per month for my ChatGPT Pro subscription. For API, they are charging a lot. How come you say it's a cost effective? So I would suggest, I mean, like it's a different problem, right? I'm trying to solve a business use case where it was impossible previously, or it is very difficult, previously, where I need a few data scientists and machine learning engineers. I need to really hire and understand all these um, data science nuances, machine learning and deep learning methods, to build all these stuff. Of course, I'm not saying like you don't need a data scientist or you don't need machine learning engineers. I'm saying this simplifies a lot of that heavy lifting today. So I would compare the human cost the existing infrastructure cost to build and train my deep learning model, how much of a GPU I would have need, how much money I've spent. If you compare that with a $50 per month for your application, and just by using some of the API services that provided by these providers, I would say still it is not. And in fact, it looks very costly at the earlier days, especially when all these large language models are came in the last year. But I think in the recent times, the price per 1,000 tokens and all like dropped like anything. It's just going lot affordable or lot cheaper these days. So, and I think pretty soon, the more open source model or the more providers are coming into the market, the cost part will not be a bigger decision maker anywhere. So that won't contribute to your decision making, you know anytime soon. So yeah, don't worry about the cost. Let's build the application, and then when you really want to scale, at that time probably you might need to worry about a little bit about the cost. Then you can move towards hosting open source model with better inferencing at your own cloud infra.
I guess again, sir, you have answered it beautifully, and I don't think that there won't be any more doubts regarding the cost effectiveness. And very true, sir, when you pointed out that it's just charging $20. Initially, when it was on beta, then we were all getting our assignments at very easily for free, but now, we have to make
I
do
think,
with,
I mean, like I think it's good. Right? I hope, I think all the students are using ChatGPT to write assignments. I'm not
yeah,
sure. So yeah, so I think it's I mean, I would think, when I want to spend like $20 for ChatGPT, probably I would. I mean, if you feel that's costly, best suggestion from my side would be like, just think that's a one more another OTT platform. So you're paying for a OTT. That's it.
sure.
That's how you should think, and then and just pay for it.
And plus more beneficial than the OTT platforms.
Yeah, of course. You learn a lot, and you can easily build cool applications. So
So, sir, moving on to the next question, sir. We
yep.
have, is LLM enough or good at predictive modeling? If yes, what would be the significance of MLDL? That is machine learning and deep learning, I guess.
Come again. Can you repeat the question once again?
Sure, sir. Is LLM enough or good at predictive modeling? If yes, what would be the significance of machine learning and deep learning if I'm not? The question is MLDL.
Okay, got it. So the question is about, yeah, if LLM can, you know, does all these predictive modeling. So what would be the, a significance of your traditional ML deep learning methods again? So it's a good question. Again, when you say LLM can solve this problem, right? LLM need not to be necessarily solving all these problems always. Correct? It depends on the problem. What exactly you're trying to solve the problem. Let's say you have a properly labeled data, a proper problem statement and the proper requirement. Hey, this is what exactly I'm going to solve this on this predictive modeling. And the data is not so dynamic in nature, so you just keep gonna get a repetitive data pattern. I would still suggest you can leverage your traditional machine learning deep learning models, wherein which the data is unpredictable and it's so flexible and dynamic in schema, where you can't build one model and that can't fit for all these different use cases, right? At that place you can explore or evaluate large language model. The one challenge, as I said, the challenge today is on LLM is it's non-deterministic, right? So um, uh, sometime, as I said, it could hallucinate. So how to mitigate that hallucination? That all some of the challenges we should take care, wherein which in your a traditional machine learning and the deep learning models, the accuracy might be much higher compared to LLM, because you trained specifically for that niche use case, not a generic use case where you go and throw a bunch of prompts and getting something. So to answer to that question, if the problem statement is super clear and the problem statement is very niche and you're trying a very specific problem where your features and the targets all are fixed and you're not going to get so many random inputs here and there, you can still leverage uh, ML DL models. And if you really want to deal with a lot of unpredictable or different data, the dynamic data, um, then you could explore large language models. Again, I pointed out already one thing, right? Runtime architecture. So today so many things have moved towards runtime architecture. So to answer this question, how the typical ML deep learning could go, the same GPT's code interpreter could really help. How the fundamental of computation or computing changes from build time to runtime, that could answer for this ML question also. Even in fact, some of these models are even coming up with very nice machine learning and deep learning a code that uses scikit-learn, matplotlib, and all these good libraries. These all things are now being generated in runtime. And in fact, in runtime itself, some of the tools have started building models. And of course, it has its own caveats like model accuracy or the evaluation or the bias and other stuff. But I'm saying there are so many area where already things are moving towards the runtime architecture, even building ML and deep learning models in runtime.
I hope Manish, your question stands answered here. And now coming to Dripto's question, if I'm pronouncing the name right. So there are things like Azure OpenAI services which bridge the gap between natural language and SQL. In Petavue doing something different? It is more a company specific question.
The question is, if Azure solving natural language to SQL, what Petavue does? Is that the question?
The question is like, if I am interpreting the question correctly, it is that Azure OpenAI services bridges the gap between natural language and SQL.
Mm-hmm.
What is Petavue doing different? How is Petavue different from Azure
Okay,
OpenAI
okay.
services?
Yeah, I think the understanding here is slightly different. I'm not doing anything special, or we are not building a model that does natural language to SQL, right? So I'm also using one of these models to do the natural language to SQL. But as I said, it's not that straightforward. It might have its own challenges, like all these hallucination or unpredictable or non-deterministic outputs. We have to solve it really well. And my core problem, or better, we're trying to solve a problem of a different enterprise analytics, not natural language to SQL. Natural language to SQL is just a small part of a product. It's like a very small unit of the entire product. So my whole product is, it's a kind of a it's cluster of so many different operations, different moving components of large language models and couple of ML and deep learning models, and a few open source and as well as closed source models. Like we have had like multiple tens of different moving components internally that helps to solve this analytics problem, and then insights problem that exists today in enterprise. I'm not doing any model that takes natural language and convert to SQL. No, I'm just using it.
So it was very clear, and I hope the question is again answered. And now the upcoming question is more of a personal recommendation slash suggestion that is required by Prasanna. So
Hmm.
he's actually trying to build a use case using LLM. It's a summarizing, analyzing system, which
Hmm.
he's trying to deploy in a pipeline which gets updated whenever a review drops in. And he has
Hmm.
tried some methods and is facing some issues and would love to hear his opinion suggestion. So, sir, if you allow, like, if you want to get greater details about his project, should I allow him to speak up?
Yep, go ahead, no problem.
Prasanna, please unmute yourself and
Mahesh, can you please allow? Mahesh, requesting you to allow Prasanna to speak. Abhilasha, can you please take care of it?
Whom I should coach, ma'am? Sorry.
Naman, let's wait till it happens. In the meantime, if you have any more questions, go ahead.
Ma'am,
sure,
whom I
ma'am.
should coach, ma'am? Sorry.
Yeah,
Mahesh,
Mahesh.
sir,
Prasanna thing, no, ma'am. Yeah,
Yeah.
I have coached it.
Am I audible?
Yes.
Yeah. So like let me see. You would have seen Amazon, right? Like you would have seen any product page in Amazon, right? So
Mm-hmm.
the new feature that I saw recently in Amazon's page was that AI suggest AI summarizing reviews, all of the reviews. So there are
True.
1,000+ reviews. The AI summarizes it, gives a short summary, and gives some positive points and negative points, and some neutral points also in some cases. So I'm trying to build the same thing, but I'm trying to add more value here. Okay. So even though this looks like some kind of a large project, but it's kind of not, as I have uh, researched. So what I did was I directly went to Hugging Face, and in Hugging Face I tried using their library, Transformers.js library, and I tried importing some of the I tried using their summarizing tool. Okay, so the problem that I'm facing is that I'm trying to experiment here. So what I did was I loaded it in Replit and I'm trying to run it there. But I don't know what's the problem with that. Every time I click on run, I try to run my code. It is it is going out of memory and I could not complete the summarizing part. Uh, yeah, so this is the problem that I'm facing. And for say, doing sentiment analysis, it is working. But mainly for summarizing, and that too, I only have about 10, an array of 10 objects, and I'm trying to summarize that only. So this is the problem that I'm having, and I want to have your suggestion or opinion.
Okay. I mean, again, it's kind of little unknown for me, right? Like what type of error that is, what is the machine config that you use in Ripple. But I can just give a generic idea what could have gone wrong here. You're just taking this transformer and run it in Replit, correct? So you should check what is the capacity of your Replit, because when you say summarization, is it under the hood required any a GPU memory or a GPU computation? So it has to deal with any local, model inferencing. If it is there, probably your Replit uh, might not have that capacity. So it will go out of memory and just break. That could be one possibility, right? Or if you take a simple model and put it in your local machine, use the same transformer, a library from Hugging Face, use your your laptop, probably take a smaller model and still, I hope if you have like some, a decent amount of GPU, that should work. Um, I would suggest a better
Yeah.
choice here is, if you are, the goal is summary, you have to feed like array of 10 text, or 10 or array of 100 text, whatever, right? And you need a summary. I would suggest to go and experiment some of these API as a service first before diving or deploying the models by your own, because that added additional overhead, like this memory complexity, this, so many other, computation related complexities. The simple approach would be, you can take some of this API as a service, even in Hugging Face. Hugging Face provides serverless endpoints. You have to pay, of course, it not comes as free. You have to pay $9 per month, but it's worth for your experimentation, correct? So if you really want to learn something, you can invest that $9 and then create a pro account. They provide serverless endpoints, so you can use that serverless API endpoints. To that API endpoints, you can send these array of the text or a chunk that you have. You can construct a system prompt and the user prompt. You can ask a question and it would be able to answer really well. And that's a very easy solution because you have to put that boundary, right? What exactly you're trying to solve? Are you trying to solve a problem of summarization, or trying to solve problem of deploying model on your own and hosting in your local machine, or host it in your replit with the transformers? So there are two different problems, right? You're trying to solve. If your problem is on the solving summarization, then you can happily go and use some of these API as a service and move ahead. Or if you want to really learn more thing about this replit transformers, how to deploy it and everything, then you should experiment with installation or take that model, deploy it in your own machine, and then you can play around with that. So it's a two different problem that you have to choose which one you are solving.
Yeah. As you said, like I already tried using API. I mean, when Gemini popped out, I tried using Gemini. So I set it up the secret key and everything, and I tried up summarizing it. It works perfectly. But this use case that I'm trying is actually I'm trying to build a proof of concept here for a client. So I cannot disclose more than this. So um, that is why I'm trying to use or an open source model which don't store the data of a client, so that if I'm pitching this proof of concept to a client, and then I can directly say this is an open source model and it is running locally, and
Yeah,
there is no
then I
this
would
cost.
highly suggest you can't. Yeah, Prashant, I think then Replit is not a correct platform here for you. You really want to pitch this to your customer or some opportunity, then you should go with either RunPod or some of the simple easy to machine which has at least a decent capacity of GPU, where you can go and run any of these transformer models with good inference engine. You can get good result over there. Replit, I don't think it's a good platform for experimenting LLMs especially.
Yeah. Thanks, Mr.
Thank you.
Jairaj. Yeah. So, Prasanna, if you have any more questions, please send it to us. We can pass it on to Mr. Jairaj. Okay.
Yeah, no
Um,
problem. This is what
thank you.
I
Thank
was
you.
I had.
Yeah.
Thank you,
Uh,
Prashant.
and Mr. Jairaj, one question that most of our learners have in mind is, if they are up to applying for a job at, say, Petavue, now that what you have described seems very interesting for some of our learners. So what kind of opportunities are there, and what is the skill set that you will expect from students at, let's say, as an intern versus a full-time job, and so on? Can you please shed some light on that?
Yeah, sure. As I said, like here, the job will be mostly, around all these large language models. Uh, Interns has to be heavily working on, um, prompt engineering just to start with, and then they have to build really good application using RAG, and then they'll move towards fine tuning, and things are in large scale, right? So here it's not about, oh, I just write some prompt and it works. Here we need people, um, and who are um, ready to learn, and then ready to invest their time on learning all these cool advanced technologies, so that they can contribute to the company, as well as they also grow. That's a culture. You grow, me grow, company grows, right? So that's a kind of a culture we follow here in Petaview. In terms of work, as a intern, interns will be heavily focused on the fundamentals of all these large language models. They'll contribute to the prompts, RAG, and then improving accuracy and mitigating all these challenges on RAG. Uh, so after the completion of internship, they'll have a thorough understanding of how to build a software, how software in general works in real world, how to scale it, how scalable software works, how distributed computing works, and how large language model can fit into this whole scalable architecture, and how to build some serious product that serves for business with higher accuracy. So this is something as an intern they learn. So um, in terms of skill set, we would expect um, I'm not going to specifically anything skill set, but we need people who are really smart. They can quickly learn anything, right? So that's a fundamental criteria for me. And on top of that, if you really want to name something, I will put Python, some level of JavaScript, and some understanding about SQL databases, and good fundamentals about some computer science basics. They should be able to know how in general compute, process, memory, system works basically. These are the fundamental criteria I'm looking forward actually. So nothing,
Thank you so
no other
much.
magic.
Thank you.
It just,
Thank you.
yeah.
It's hard work. Yeah. Thank you. So,
Yep.
do we have any more questions or shall we wind up?
Ma'am, we have a few more questions.
Okay, Mr. Jairaj, how much time do you have? Quick, couple more questions.
Yeah, we have a couple more questions.
Yeah,
Good
Naman.
enough, no
So
problem.
just take one or two more questions and then we'll close the session. Okay.
Sure, ma'am.
Yeah, go on.
Uh, okay, so I'll bring to you the next question. And so it is from Dharyashree Patel, and he really wants to master the space of LLM. And he has worked in multiple internships, learned language chain, Llama index, etc. And there is a according to him, there is a buzz around LLM agents like Crew AI, AutoGen, Cohere. Should he learn that too? Are companies using LLM agents, or the core coding is enough for him?
See, I would say the agent, the word agent, it's kind of overused and it's kind of overhyped, or it's just a way of really orchestrating your platform well. That's called agent. So um some good uh, programming skill with good designing a mentality or a designing approach, uh, you can solve this problem really well. You need not to go and jump learn about Cohere or all other fancy models, right? It's something like, if I want to compare, if you study a good programming language, good in the sense like a programming language in a good way, right? It could be a Java, Python, JavaScript, whatever. um, Understanding frameworks is very easy. Let's say, take an example of Python. If you're good at Python, writing Flask or Django or Fast API, it's not a big deal. Same way, if you are good at JavaScript and Node.js, doesn't matter. You can write it on Nest.js, or Express or Feathers, doesn't matter. So you can go and build such, you can build application on top of those frameworks very easily, correct? The same way I would put. So, he should understand the fundamentals of these LLMs, prompting, RAG, fine tuning, all those things. Agents is just a purely a bunch of software or a code that really splits problem into smaller problems and just orchestrate well. That's it. That's the agent architecture. Nothing fancy or no magic under the hood. It's just bunch of independent moving components that stitch together. That's all.
There is Sheil. I hope you have a new perspective to your approach. And now, sir, coming to the last question that I'll be taking up, it's from Yogesh, and he wants to know that how can we ensure that the results we are getting from the LLM models are accurate enough to proceed with, where we can read and judge responses we get from ChatGPT. It's hard to do the same for larger responses or complex results.
Yeah, it's actually a very superb question, you know, which is something entire industry trying to answer, right? That's a reality today. There are so many mitigation technique. There is no solution exists for for this problem saying like, oh, this is how you should solve this. This is how you can evaluate it. No, lot of technique. Uh, as I said, this industry itself evolving. There is no best practice or there is no standard for this evaluation. Of course, people build a lot of standards. Let's say, as I said, NL to SQL, there are like bunch of people coming up with standards. So if I ask a question, if it is a SQL query, you should have this particular keyword, the joins, the subqueries, whatever. But end of the day, if the query doesn't work, no matter whatever you compare all these keywords, joins, all these things, but the query result is wrong, then it is wrong. That's it. So that will come to know only when things gone wrong and someone noticed, right? So some of the evaluation frameworks are there, like usually few companies are already trying to solve this problem. Whenever you're getting some answers, the harder problem here is the NL to NL problem. NL to SQL or NL to code is uh, significantly or comparatively less problematic in terms of measuring the accuracy or how good the answer is. How I would say how, right? Like, you got a SQL query, you can go and execute and get the answer. If the query executed successfully, it is compiled successfully, there is no syntax error, there is a chance, okay, at least the query is syntactically correct. And then the next step would be, is it meaningfully correct or not? Is it giving a right data or not? That is the second problem to solve. That second problem, today there is no straightforward way. That is something over the period of time we should build a framework to solve such problem. Same, the code, you got a code, you go and write it. If it compiled successfully without any syntax error, which means it's syntactically correct, but is it logically correct? Don't know. That is something still a human evaluation required today, right? So that's where companies are bringing a lot of good frameworks. Depends on the industry or the domain they are trying to solve the problem. Like mine is, let's say, I'm solving, for example, sales or a marketing industry. You always evaluate with marketing related terminologies or sample response. So you'll just have your own evaluation frameworks internally. You just take the result internally. You can build a small programmatical a layer using programs that can compare some of the patterns and then give the final output. These are like small mitigation technique, but there is no a golden a rule or a rule of thumb or a standard established, at least so far. It's we are not there yet. It's the whole industry is, it's kind of evolving. So but eventually we will be there. That's the hope. it's
Thank you,
it's like,
sir.
in the olden days, probably you could have written all the things in hand and paper. You could have calculated, right? At the time, the same question would have come. Oh, you're saying computer or calculator does this all the maths, but how I will believe the answer from the calculator is correct? In my mind, I know 10 plus 10, 20, and 20 plus 5, 25. How the calculator works? Probably the same question would have been exist 50 or 60 years ago, while people invent calculator. Or same thing would have been for computer. Same thing would have been for your internet. Oh, is it even possible how to send a message from one place to another place in the world? That's, will it even reach to the correct people? Or the same question would have been exist when the cloud computing comes. Oh, if I have my server, everything in my office, my data is safe, but if I keep my data somewhere in the cloud, how it is safe? No, that is not secure. I'm just giving my data somewhere and it's not a safe. Same question should have been raised at that time, but today everything is in cloud, right? People no more asking the question, hey, should I believe cloud or not, right? I think the same way the LLM space also will evolve, and it will eventually answer for all these questions. It's a lot of standards, best practices, and techniques will evolve, and yeah, that's the solution.
And just answer, it's very evident that we are at the tip of the iceberg and there's much more to delve into. So, coming
Yep.
ahead, I would firstly like to thank you, for coming up, taking time out of your busy schedule, communicating with us, expanding our horizons. And sir, it's truly insightful. And the way you speak, the way you inform, and the way you humbly answered all our questions, it truly matches your stature and why you are where you are today. So thanks a lot, sir, for coming to us and talking to us. I would like to thank Kamala ma'am and Suraj sir for allowing this event to happen. And I would like to thank all the entire IIC team and the Student Placement Council to actually make this happen flow effortlessly. And it was a really great event where we all learned. And I hope, sir, you had a great time. And I feel that we'll be learning a lot from the session and maybe contributing in the future with your company or somewhere else to the community.
Yeah, thanks, Naman. Thank you.
Sure,
Thank you,
sure. Thanks a
Jairaj.
lot. Thank you so
Thank you
much.
so much. So our students definitely they will look forward to coming and working with you and your team. We look forward to that, and we'll be in touch with you. Thanks again. Thank you so much, and a special
Thanks.
thanks
Thanks
to
so
the
much. Yeah.
SPC team. We have a student placement council team who helps us in all our activities. So a big thanks to them also. Thanks again, Jairaj. Thanks. We'll be in touch. Thanks.
Awesome. Thank you. Thank you so much. Thanks a lot. Bye.